Hi everyone, this is the presentation video for the second course assignment in the AI product management specialization. So starting with the problem statement. My problem statement for this project is thunderstorm severity detection. So let's dive deep into it. Starting first with the opportunity evaluation. So for the need, around 40,000 storms occur every day in around the globe, according to our research, and this also affects the socioeconomic impact the socioeconomic lifestyle of the people living in the area in a negative way. So there is a need to identify what severity of this thunderstorm may go up to, and so this is a real time problem for several disaster management organization. And currently there is no system which is current used for this type of detection. And talking about the heuristic approach may work or not. See, the heuristic approach may work for a single state, but it may not work universally because each state has its own geographic location. So standard heuristic rules may not be applicable for every location. For such complex relationship, we need machine learning models which also have option of neural network at the end. So to understand very complex relationship, we need to use machine learning for this project. So defining a clear-cut problem statement. So for given the problem statement states as the given the occurrence of a thunderstorm in any place, the machine learning system should be able to provide the following outputs. Starting with the first one is the severity on the scale of 0 to 3, followed by the possible human displacement that may occur, followed by the area that can be affected in meters, and the possible nearest relocation space according to the human displacement and the severity which is low around the area. So the possible approach for this would be to use a machine learning solution and given outputs like state, month of occurrence, and other factors and other features. First, the machine learning system should be able to produce a severity score based on that. Using the severity score, it should be given as a input and along with the other features to predict the human relocation in the area that can be affected. And followed by this, the machine learning system should do similar work for all the nearest neighbor locations and should be able to produce the list of possible nearest relocations. Validation. So for validation of this problem, a series of experiments are to be conducted. For this particular problem statement, the hypothesis states that there is a correlation between the severity and the human displacement in the area that can be affected. And testing the hypothesis is finding the correlation with other features and the severity. See, there are other features like current condition, rural and economic conditions of the area that is affected by the thunderstorm, but that cannot be considered into the experiment. So we need a series of experiment to lead to a more machine learning clear cut machine learning system. Success metrics. So the success metrics for this are divided into two parts: output based and outcome based. For output based, the problem statement for severity estimation is a classification problem. So it can be evaluated using confusion metrics and all of the other metrics like precision, recall, and etc. Log loss value, etc. And for the human displacement and area affected, that it is a regression problem. So the regression metrics like R square, RMSE, mean absolute percentage error can be used. And for the nearest possible relocation, first we need to do a manual labeling and the predictions that can be gauged. And specifically for nearest possible relocation, there should be 100% accuracy. And for outcome based, so the outcome base can be predicted by applying this system to and giving the system to some organization and let them check the system during a ongoing thunderstorm disaster event and checking the final output of the model versus the real output of the model. So this can be used to see how real time it may also work. So ML system design. So for the three most basic ML design constraints, the first one is edge or a cloud. For this, a constantly new model should be used. So for this, we need a cloud-based model followed by online learning should also be followed for each new event. On learning should be done in the system and it should constantly improve. Followed by batch or online prediction. So the online prediction is to be done because it is not afford we cannot afford a delay in batch learning using the batch prediction system. So we need online prediction system in this case. And the risk are basically of two types: the risk of wrong prediction in the case of nearest relocation, and the risk in the case of data drift, because there is a constantly changing environment and sometimes the thunderstorm events may have not occurred due to rain but some other environmental conditions which cannot be considered into the model. So there is a possibility of the data and concept drift and followed by low accuracy of the risk. So this was all for the problem statement. Thank you.